Now let's take a look at this word problem. The length of a new rectangular playing field is 7 yards longer than quadruple the width. If the perimeter of the rectangular playing field is 454 yards, what are its dimensions? So let's draw a picture here. We're told that it's rectangular. It's a rectangular playing field. So kind of like a football field, soccer field, rugby field, something like that. Alright. The length is 7 yards longer than quadruple the width. So the width, I'm going to call x. I don't know what the width is. I'm just going to call it x. So if that's x up there, this is x down here. Alright, now the length, that would be this side or this side, is 7 yards longer. So 7 yards longer than quadruple the width. Quadruple means 4. So that means the length has to be 4 times the width. And then it says 7 yards longer. So that's plus 7. So this side here, this is 4x plus 7. This side is 4x plus 7. Alright, if the perimeter of the rectangular playing field is 454 yards, what are its dimensions? Perimeter means all the way around, right? So we know the perimeter is going to equal 454 yards. So if I can add all these sides up and set it equal to 454 yards, then I can solve for x. So let's add all the sides up. So I have x, starting up here at the top, plus 4x plus 7 plus x plus 4x plus 7. So I've added all the sides up. So that has to be equal to 454. So let's put like terms together. So x plus 4x plus x plus 4x, that's going to be 10x plus, and then we have two constants on the left side, 7 and 7, that's 14, equals 454. To solve for x, you need to get the 10x by itself first. So subtract 14 from both sides. So 10x equals 440. So x equals 44. What was x? The width. So the width is 44 yards. What's the length? The length is 4x plus 7. So 4 times 44 plus 7. Alright, so that's 167 plus 7. 176 plus 7, or 183 yards. Alright, so width is 44, length is 183. You would see something like this, 44 by 183. Or you may just see width equals 44 yards, length equals 183 yards. For a problem where you're trying to figure out width and length, it's always best to draw a picture. Kind of makes a little more sense if you do that. Any questions on that problem? So draw a picture, it helps, I promise you. Makes a little more sense if you can see it like that. Okay, let's look at this one. For some reason the problem went to the bottom. Sorry about that. City cabs charge a $2.50 pickup fee and $1.25 per mile traveled. Diego's fare for a cross-town cab ride is $20. How far did he travel in the cab? Alright, so this one's pretty straightforward. We know that he paid $20. So whatever equation we come up with has to be equal to $20. So the cab charges $2.50 to pick him up, and then $1.25 per mile. So how did we come about having to pay $20? $2.50 to pick him up plus $1.25 per what? Mile, and that's going to be our variable. We want to know how many miles he went. So there's our equation. Solve for x, so you need to get the x by itself. So subtract 250 from both sides. So I have 125x, $1.25 times x equals 1750. Divide both sides by 1.25. So 1750 divided by 125 equals 14. So how far did the cab go? 14 miles. That's how far he traveled. Okay. So that one's pretty straightforward. Are there any questions on that one? Now, in chemistry, physics, even in accounting, different classes like that where you have formulas, a lot of times we want to take a formula and solve for one of the variables. So regardless of what the formula is, we can solve for a variable in the formula by just using our order of operations and not doing anything that breaks any kind of math rules. For example, Let's say that I had our formula from earlier. Interest equals principal times rate times time. And I wanted to solve for rate, or solve for R. We don't even have to know what this formula does to solve for R, as long as we understand that, okay, whenever you write variables side by side, that means you're multiplying. And what do we do to get a variable by itself when you're multiplying? You divide both sides, right? There's no other term on this side other than PRT. And so if I want to solve for the variable R, I need to divide by P and divide by T. And what you do to one side of the equation, you have to do to the other. So dividing, remember, that'll cancel out. And now we're left with R by itself. So that means we have solved for R. So we have R equals I divided by P times T. Alright, so we should be able to solve for any variable in any formula just by following the regular order of operations and doing the same thing that we would do in an equation. Alright, let's look at another example. Oh no, go to a new page real quick. Alright. Let's say that we had, we did some perimeter earlier. Let's say we had P equals 2L plus 2W. That is the formula for the perimeter of a rectangle. If you know the length, L, and the width, W. Well, let's say that we wanted to solve for one of the other variables, like say the length. Let's solve for L. Alright, so let's look at our formula. To solve for L, that means we want to get L by itself. So if there's any other terms on the same side as L, as the L term, we need to move them to the other side of the equation. There is another term, right? Here's a plus 2W. So let's take this plus 2W and let's move it to the other side of the equation so that we can get the L term by itself. Alright, to move this over to the other side of the equation, what do? I say minus 2W to both sides. So P minus 2W equals what? 2L. Now I have the L term by itself. What do I do to get L by itself? Divide both sides of the equation by 2. So I've solved for L, the length. You can find the length by saying the perimeter minus 2 times the width, all divided by 2. Make sure that you divide it all by 2. Now, the unsure math student would try to do something like this. They would try to cancel that out. But it doesn't work unless you can simplify by what's in front here and here. So you can't just cancel that out. If there would have been a 2 in front of the P, then you could cancel out this 2, and this 2. But since they both don't have a 2 in front, That's our final answer. Alright, so we should be able to solve formulas like that by just doing the order of operations, or the order that we would if it was an equation. Alright, try this one. Let's say I had S equals C plus N times M. And you don't even have to know what these formulas mean. I want to solve this formula for N. Alright, so the term that has an N in it is this term. And I have N times M. So the first thing I need to do is get this term on one side of the equation by itself. To do that, I'm going to have to move this C over to the other side. Now, since there's no sign in front of the variable C, this is a positive C. So if I want to move it over, I need to subtract C from both sides. Okay, so I have S minus C equals N times M. Now, to get N by itself, since this is NM, that means you're multiplying. So to get rid of this M here, you have to divide. So if I divide the right side of the equation by M, I need to also divide the left side of the equation by M. So I have N equals S minus C, all divided by M. I've solved for N. Alright, we're going to do one more. What can make this a little bit more complicated is if you have a formula where you repeat a variable, but you want to solve for that one variable. For example, if I had the formula, let's say A equals B plus B R T, and I wanted to solve for B. What makes this problem a little different than the others is that I have a B here and I have a B here. And so if I was to just take and move one of these terms over, well, I'm going to have a B on both sides. Okay, so I want to be able to somehow only write one B in this formula. The way that I can do that is I can take and I can factor a B out of both of those terms. So if I factor a B out of this first term, what does that leave? 1. Plus, if I factor a B out of this term, that leaves me with RT. Now, I have B times my crazy looking 1 plus RT. Now, to get B by itself now, since I'm multiplying this B times that, you have to divide both sides by 1 plus RT. And this one will cancel out. So my answer is B equals A over 1 plus RT. 20. And that finishes up our word problems.